Hey guys, this is 12.4, the last lesson of Unit 12, and in this one we're going to be finding volume of composite solids. So what a composite solid is it's just something that's made up of two or more solids. Sometimes they're going to be two things that are added together. Sometimes there's going to be like an empty space, a void, so a solid subtracted from another solid. Really, there's nothing new here. The biggest thing is to just stay organized. You're going to be finding multiple volumes, so keep your work very organized. And if this unit's been going well for you, should be nothing too new here. So we'll just go ahead and do an example. You can draw it. It's kind of like a weird looking house. It looks like it has a prism, a rectangular prism on the bottom, and then it looks like it has a rectangular pyramid on the top. So we're gonna be finding those two volumes and then adding them together, okay? So I'm gonna color code things a little bit here. So I am first going to just kind of be looking at this red piece, and that is a rectangular prism. So I'm gonna write that down. I'm gonna find the volume of it. So remember that one was the simple one that was just area of the base times height of the prism. Okay, so our base, it's kind of hard to see, but I am going to use this 11 by 9 base. Okay, so I'm kind of just picturing the bottom of that. So my base is a rectangle, and it is 11 by 9, so it's 99 square feet. I'll just leave it as 99 for now. Okay, and then the height of that one is 2 feet. Okay, so the total volume is 99 times 2, which is going to be 198 feet cubed. And then I kind of meant to keep all of that red, so I'm going to go back and change that so that it's all red. Okay, so that one's done. And then the next one is this rectangular pyramid. And we haven't really done much of those, but it's a thing. And a rectangular pyramid is going to have the formula 1/3 base times height. Okay, now the nice thing is the base is exactly the same. Okay, we're still using that same rectangle for the base of the pyramid. So I can just right away write down. So we're finding the base of, I guess I'm going to say rectangle again. It's still going to be 99. Not even going to redo the math on that one. Okay, now the height is this distance here. Remember, your height is always from the middle of your base straight up, creates a right angle, so 15 feet. Okay, so now we can plug that in. We're going to do 1/3 times 99 times 15. So I'll grab Desmos for that one. 1/3 times 99 times 15 is 495. And that is in cubic feet as well. Okay, now our final answer is going to be the sum of those two things, right? We have our base, which is a rectangular prism, plus the top, which is a rectangular pyramid. So our total volume is going to be equal to this one plus this one. 198 plus 495, which is 623. Sorry, that's wrong. Hold on, 198 plus 495. I typed in 425, 693. And those are in cubic feet. All right, so that's it for that one. And then our second one is this one. So we have a tennis ball can. Again, do your best job at drawing that. Just your standard tennis ball can. And the question is, how much air is in the can. So you can see that there's some space in here. We got some air surrounding our tennis balls. So all of this area in here, all this area in here. All right, that's all empty space. So how are we going to find how much air is in there? Well, we have to start with the total cylinder. So we're doing cylinder minus our tennis balls. Well, our tennis balls are spheres, and there's 3 of them. So we need to do cylinder, take away 3 spheres. Okay, so again, this is where we just need to make sure that we stay organized. So I'm going to start by doing the cylinder in blue. So volume of a cylinder was just base times height. And the base is a circle, so pi r squared. And in our case, half of 3 is our radius, so 1.5. So pi times 1.5 squared. And I'm just going to use my own calculator here to speed this up. So pi times 1.5 squared is approximately 7.07. And then the height of our cylinder is 8.4 inches. So the total volume of our cylinder is 7.07 times 8.4, which is about 59.39 cubic inches. Okay, so we're good there. We got the cylinder. Now we need to find the volume of some spheres. So I'm just going to start with one sphere. I'll do it in green because tennis balls are green. Okay, we're going to have the same radius. We're going to say that that tennis ball is really tight inside the can. So it still has a radius of 1.5 inches. And the volume of a sphere, we have to remember that we have 3 of them. So we'll get to that. Volume of a sphere is 4/3 pi r cubed. So our radius is 1.5, so I'm just going to go ahead and do that. 4/3 pi 1.5 cubed. So I went ahead and typed that into Desmos, and we get about 14.14. Okay, so that's for one tennis ball. So now we need to make sure that we multiply that by 3. So I'm going to write that down. 3 tennis balls would be 3 times 14.14. 3 times 14.14 is about 42.42 inches cubed. Okay, so now to find our empty space, or our air is going to be our cylinder, what we started with, minus the volume that was taken up by our actual tennis balls. So if we do 59.39 minus 42.42, we end up with 16.97 cubic inches of air or empty space within our can. Okay, so I would say that this is something they definitely use out in the real world when they're packaging. You know, especially now with all the Amazon stuff that comes to your house, they do a lot of work trying to conserve space and trying to use as much empty space as possible. So again, just stay organized on this one. If you have any questions, anything's looking too confusing or too much of a mess, just let me know and I can help steer you in the right direction.